Okay, welcome, honor chemistry students. This is Mrs. Snyder, and this is a lesson on how to balance chemical equations. This method is really based on trial and error, and what I have here are just a few of what I would call examples or things that I have learned to make things a little simpler. The first thing I would say is that you eliminate odd even first. So what do I mean by that? I would mean something like you would not start with like if you have two evens on each side. Also, I do not start with carbon, nitrogen, oxygen, hydrogen. I typically do those last. And if there was something unique, like maybe a magnesium or a sodium, that would be one compound that I would work on first. You always want to add the lowest whole number coefficient, so that coefficient has to be a whole number, and you want it to be the lowest multiple. We don't write coefficients of 1. They're understood to be there, but we don't write them. And never, ever, ever change the subscript in a chemical equation, okay? You only can balance by changing a coefficient. You can never change a subscript. You're going to do single elements last. If there's a polyatomic in both reactants and products, you could treat that as one unit, and I will show you how you can do that as well. And at the end of the lesson, we're going to show you a special equation called a combustion reaction, and you are going to be able to use a fractional coefficient. So I will show you how to do that as well. So those are the tips that I've learned on balancing equations, and really the best way to begin this is to just get started. So let's do that. Okay, so in this balance equation, you'd have iron plus oxygen making iron 3 oxide. The first thing that I do is I write a little T-chart, and you do not have to show me your work or do this, but I find it helpful when you are beginning writing balance equations that you can kind of keep track of the reactants and the products. And so I'm going to write the elements that are involved in this reaction, which is iron and oxygen. And the first thing I'm going to do is count how many irons we have on the reactant side is 1. And there are 2 irons on the product side. Oxygen, we have 2 oxygens, and on the product side, we have 3. So when I do this, and I'm looking at this chart, I realize that I am not balanced in iron or oxygen. I could start with my iron, but that will not at all help the oxygen. So when I see like the oxygen being in a 2 and 3, that kind of tunes into me that that's where I need to start. And with it being a 2 and 3, the common number between those two are 6. So I think to myself, what do I have to do to get 6 oxygens? Well, if I were to get 6 oxygens, I would put a 3 here. So now here's my coefficient of 3, which now will make that 6 oxygens. And then in order to get 6 oxygens here, I will put a 2 there. That's going to get me 6 oxygens, so I'm going to change my T-chart. But that also affected my irons. I now have 4 iron, but that means I can just put the coefficient of 4 in front of this iron. So now I have a 4 here as well. So now I have a balanced equation. You can always check 4 iron, 6 oxygen, 6 oxygen. I have a balanced equation. Oh, okay. The next one would be something like this. Again, I'm going to do reactants, and I'm going to do products. I'm going to write my compounds. Now notice you have a polyatomic here, but you don't have it here. So I have to write out each individual ones, the oxygens, the hydrogens, and the chlorines. That's what's available. I have 1 magnesium on each side of the equation. Oxygens, this 2 gets distributed like in math. There's 2 oxygens because of that 2 right here. And notice I have 1 oxygen. I would have 3 hydrogens because I have to count these 2 plus this hydrogen. And here I have 2 hydrogens. And now I also have chlorine. I have 1 chlorine and I have 2 chlorines. So if you would recall back in the kind of rules or list of suggestions that I had, I don't start with hydrogen and oxygen first. I would be looking at some of the more unique elements, and I notice that magnesium's balanced, but my chlorine isn't. So what I'm going to do is I'm going to put a 2 here in front of the HCl. That's going to give me 2 chlorines, but that also changes my hydrogens now to 4 because I have 2 hydrogens here and I have 2 hydrogens from the hydroxide ion. So that's going to change that to 4, which now means that the only place that I have hydrogen on the product side is here. So I'm going to put a 2 there to make 4 hydrogens. And that allows me to have 2 oxygens. And now I'm completely balanced. This equation is balanced. When you do have a polyatomic on each side, you can treat that as one unit. So here I've got reactants, here's my products, I'm making my T-chart. Now I'm going to write silver. I'm going to write the NO3 and as one unit because you see it on both sides, and I'm going to write copper. And this can really help you to find like where to begin the balancing. So when I have one silver, let's see, the nitrates I have 1. On this side, I have 2 nitrates. And with my copper, I have 1 and 1. So this just really tells you the place that you need to start. I need to put a 2 in front of the silver. When I do that, that gives me 2 nitrates, but it also changes my silver. Okay, so then I would have to then put a 2 in front of that silver. So now this becomes a 2, and I'm at a balanced equation. What about combustion reactions? Well, combustion reactions is a classification of reactions, and you will know you have a combustion reaction because you're always going to have something called a hydrocarbon. And a hydrocarbon is literally hydrogens and carbons together. Typically, they're written carbons first, and then you have hydrogens. So you have some amount of carbons, and you have some amount of hydrogens. And they will react with oxygen to form carbon dioxide and water. When it's time to balance a combustion reaction, you will want to always balance it carbons first, then hydrogen, and do the oxygen last. Because the oxygen is a diatomic, you can use fractions in front of a diatomic. And I'm going to show you guys that right here and right now. Okay, so here is a combustion reaction. And I would need to balance this. In order to balance this, let's see, it looks like this got off kilter a little bit, so I'm going to see if I can just move that over a little bit. Yep. So in order to balance this, I'm going to use that system of doing carbons first, then I'm going to do hydrogens, then I'm going to do oxygens. So that's how I'm going to balance it. So I notice here I've got 3 carbons, so I'm going to put a 3 here. 3 carbons, 3 carbons. Next I have to do hydrogens. So I have 6 hydrogens. I have only 2 here, so I would need to put a 3 here. And lastly, I'm going to balance my oxygen. Well, when I balance the oxygen, you'll notice I got 6 oxygens on the product side from 3 times the CO2 would be 6. And then I've got 3 more, which gives me 9 oxygens. And here's the problem. 9 is an odd number, and you have to multiply it by 2. So what number could I put here in order to get 9? Well, I can use the fractional coefficient of 9 halves. I don't know what's going on with my board there. Here, let's try to erase that again and get this a little clearer. I can use the fractional coefficient of 9 halves. So I can write 9 halves right there. And now it will be balanced. You can only use this in front of a diatomic. And notice that oxygen's diatomic, so that's why you can do this. If this bothers you, and there's going to be situations when we're going to want to get rid of the fraction, you can just multiply everything by 2, And that still would be the lowest whole number ratio that we had talked about. This would still be an acceptable balanced equation as well. Okay, so I will accept either way. You can put a fraction in front of the diatomic, or you can draw it out as in the example below. I hope this helps, and good luck.